morning, students. Myself, Vijay Shankar from EC Department, Chevrolet Engineering College. Today, we are going to discuss about some more examples in the electrostatics, the Unit 3. The last two classes, we completed some different types of examples. I can see the another examples. You have to find the D bar in Cartesian coordinate system. Find the D bar, nothing but it is a electric flux. In previous class, we find the electric field, the different examples. E bar is equal to infinite line charge. E bar is equal to rho L by the 2 pi epsilon naught R into AR bar. And E bar is equal to, it is an infinite sheet of charge. The same E bar is equal to rho S by the 2 epsilon naught AN bar. Okay. Now we can find the electric flux density D bar in Cartesian coordinate system at the point P. For 40 millicoulombs at the origin. You see here. At the origin, there is a charge. The charge is 40 millicoulombs, 10 to the power of minus 3, 40 into at the origin. And the P is a uniform line charge. A uniform line charge, rho L is given. Rho L is a 40 micro into 10 to the power of minus 6 coulombs on the z-axis. It is on the z-axis. Means D bar is equal to rho L by the 2 pi R into AR bar. That is a formula to find when given the line charge rho L is equal to. And uniform charge density, rho S is given. That rho S is a 57.2 micro 10 power minus 6 coulomb per meter square at x is equal to 12 meters. Okay. See the formulas what we have already. The E bar is equal to at the point charge the Q by or the differential electric field intensity dE bar is equal to dQ by 4 pi epsilon naught R square into AR bar. This is for the point charge. The point charge is located at the origin, the 40 millicoulombs. This is a formula for the electric field intensity. And similarly, the another E bar is equal to rho L by 2 pi epsilon naught R into AR bar. Is for the line charge, infinite line charge. Okay. Next, the C is saying that is a uniform charge density rho S. So E bar is equal to rho S by the 2 epsilon naught AN bar. The same formula you have to use here also to find the electric flux density. What is the relation between of electric flux density and electric field? D bar is equal to epsilon naught into E bar. So whatever the E bar is there here, E bar is equal to, now we can get it is a Q by 4 pi. There is no any epsilon naught R square into AR bar. That is for the A bit. For B bit, the D bar is equal to, here also epsilon into E bar, substitute this E bar here, rho L by 2 pi into R, nothing but here the epsilon naught is get cancelled, 2 pi R into AR bar. And C bit, C is equal to, C is a D bar is equal to, D bar is equal to rho S by the 2 epsilon naught. No, epsilon naught is get cancelled and is a AN bar. These are the three formulas you have to use to find here the electric flux density. And given that it is a R bar, you can find out at the origin here and the P. At the P, we have to find out the electric flux density d bar. So the sending end is a 0, 0, 0. Receiving end is a unload end. It is a 6, 8 minus 10. We have to find out the AR bar is equal to 6 minus 0 into AX bar. That is a 6 AX bar plus 8 minus 0 into AY bar, 8 AY bar minus 10 AZ bar. Okay, and whole divided by the AR bar is equal to, it is a magnitude of R. That magnitude of R is a 6 square 36, 8 square 64, and 10 square is 100. 6 plus 3 is the 200 under root of 200. So this is a AR bar, 6 AX bar, 8 AY bar minus 10 AZ bar into under root of 200. So first of all, you can find the D bar is equal to Q by 4 pi R square into AR. Okay, what is R here? The distance between of the origin to the point P. So R square under root of 200 whole square and 6 AX bar plus 8 AY bar minus 10 AZ bar under root of 200. Simplify this function. Write the coefficient of AX, coefficient of AY, and the coefficient of AZ. You get the first D bar is equal. In second one, the P is equal to rho L given the 40 microcoulomb per meter along the Z axis. So you can use now the D bar is equal to rho L by the 2 pi R into AR. Okay. So actually the E bar is equal to what I told, that is the E bar is equal to rho L by 2 pi epsilon naught R into AR. This is a formula. Okay. The rho L by the 2 pi epsilon naught R into AR. As the charge is along the Z axis, there cannot be any component of E bar along the Z direction. So there is no any Z value, only the X and the Y. 6 into X bar and 8 into AY bar. So here the Z is there, the X bar, Z component is eliminated to find the AR bar here. Okay. You see, and then the 6 minus 0 X bar and 8 minus 0 AY bar, there is any Z component. Since infinite line charge is on the Z axis. So AR bar is equal to 6 AX bar plus 8 AY bar. Its magnitude is 6 square 36, 8 square 64, and under root of 100 is a 10. So E bar is equal to rho L by 2 pi epsilon naught is there for the electric field test, not for the electric flux. They're asking the electric flux density. Eliminate the per meter and 2 pi into 10. 10 is a R here. Okay, 10 is a R. Denominator, whatever we have, it is a magnitude R. The D bar is equal to 3.81 into 10 to the power of minus 7 is the AX bar coefficient and AY bar coefficient. Okay, and for the last one, you have to use the formula here. That formula is D bar is equal to rho S by the 2. So E bar is equal to rho S by 2 epsilon naught. But AN bar is equal to here the AX because given that it is X is equal to 12 meters, which is parallel to the YZ plane. So rho S by the 2 epsilon naught AN bar. And X is equal to 12 means the point is at below the value. So the negative sign its representation towards the negative direction of X. So the X plane is here and the direction it shows that towards the negative direction of X. So rho S by the 2, that is a negative value. The D bar is equal. Okay. So D bar is equal to, now we can find out the rho S by the 2. There is any epsilon naught, it is a minus AX bar. Okay. Now you can see here the D bar is, it is a E bar is equal to rho S by epsilon naught, D bar is equal to rho S by 2 and minus AX bar. Directly you'll get the minus 28.6 into 10 to the power of minus 6. The rho S is given the 57.2 by 2. 57.2 by 2 is 28.6. Got it, participants? So next example is a second example. A point charge 6 microcoulomb is located at the origin. A uniform line charge density 180 nanocoulomb per meter lies along the x-axis. And uniform charge sheet of charge is equal to the 25 nanocoulomb per meter square lies in z is equal to 0 plane. Find the d bar. Okay, what they're asking here means a point charge of 6 microcoulomb. Let us take here a 6 microcoulomb. Micro means 10 power minus 6 is located at the origin. Let us take it is the origin O. I am taking here 0, 0, 0, 0. A uniform line charge density rho L is equal to 180 nanocoulombs, 180 into 10 power of minus 9 coulomb per meter, lies along the x-axis. So they are saying it is a x-axis. Means there is no any component in the x-axis, only the remaining components only. And uniform charge, sheet of charge also there. That is a example it is. Or the example. Let us take it's the first one. Rho S is also given. The rho S is equal to 25 nanocoulombs. That is also 10 power minus 9 coulomb per meter square because it's a surface. Lies the Z is equal to 0. Okay. Means you have to use to find the electric flux density. D bar is equal to rho L by the 2 pi R into AR bar for the rho L given, and similarly the D bar is equal to rho S by 2 A N bar, and Z is equal to 0 means that is a AZ bar. By using these two formulas, you have to find out the D bar at the first one. Now I am using here the A point is there to find the D bar here. Okay, is towards AR bar. What is the point here? The 0, 0, 0, 4. 0, 0, 4. But to find the D bar, when the given the rho L is equal to, it is in the x-axis. X-axis means you can take the 0, not the 0, sorry. X comma 0 as a point to the point of 0, 0, 4. Means it is a lies in the x-axis means that there is no any x component. Only we have the y and the z component. Here you see the starting end, this one is the receiving end. 0 minus 0 into AY bar is also the AY bar is a 0. 4 minus 0. 4 minus 0 is a Z value. So R bar is equal to 4 minus 0 into AZ bar. So AR bar is equal to 4 AZ bar whole divided by under root of 4 whole square. Nothing but is a 4. Got it, my students? So similarly, the AR bar is equal to AZ bar. So 4, 4 get cancelled, AR bar is equal to AZ bar. Now, the D1 means it is a point charge. They're saying a point charge of 6 microcoulomb is located at the origin. At the point charge, Q is equal to 6 into 10 to the power of minus 6. 4 pi into 4 square. That's a 4 square means the R is a under root of 4 square. Okay. R you get it is a 4 square into AZ. AR bar is equal to AZ bar. Got it, what is it? That's a Q we can find out. The Q is given the 6 into the power of minus 6, and you can substitute the 2.984 into the power of minus 8 into AZ bar coulomb per meter square we got. when we can substitute the rho L is equal to that rho L by the 2 pi r, that by the 2 pi r, rho L is given is a 180 nano 10 power of minus 9, 2 pi into 4. The r is we got it is a 4 only. Previously, because it is a point charge, we are substituting the r square. R square means root 4 given it is a magnitude of r is a root 4 whole square. That is a 4 only. You can substitute directly here the r as a 4 whole square. Here the r is different. That r is a value is a 4 only. 180 to the power of minus 4 into 2 pi into r. A x z bar is there because AR bar is equal to, we got the AZ bar. The rho L is on the x axis, the x component is eliminated. Similar, the uniform sheet of charge lies at z is equal to 0 means AN bar is equal to AZ. Rho S by the 2, rho S is given by the 2 AN bar, 25 into 10 to the power of minus 9 by 2 into AZ bar. So we got at the point charge D1, at line charge D2, and surface charge of the sheet of charge is a D3. Add all the terms, all are it is the AZ bar terms only. So 49.501 into 10 to the power of minus 9 AZ bar coulomb per meter square. Got it, my students? And the second one, what is the second here? D bar at 1 to 4. You can find out, we find now the A is 004. At B 1 to 4 also you can find out here. There's a 1 to 4. So now a Q1 is a 6 micro coulomb at the origin. And next one is the charge is on the part of enclosed sphere, rho L into length and enclosed. And the intersection of the z is equal to 0 prime with the sphere of a circle of radius of 4 meters in the xy plane. See, let us to find that is a third one, my dear students. Second here, 1, 2, 4. At the point charge, the P is 0, 0, 0, and 1 minus 0, and 2 minus 0, and 4 minus 0. You get having all the components, AX, AY, and the AZ at the point charge. Okay. AR bar is equal to AX bar plus 2 AY bar and 4 AZ bar under root of 1 square, 2 square, 4 square, you get the 121, root of 21. But in the line charge, because it is the x axis, the rho L is distributed uniformly, there is no any x component, only the y and the z components. So 2 AY bar plus 4 AZ bar under root of the 2 square and the 4 square. That is a 16 plus 4 is a 20. Previously, it is a 1 square is also there. Then we got the D2, rho L by the 2 pi r into AR bar. Substitute that one, you can find out the AY coefficient and the AZ coefficient. In the D1 also, we got the AY coefficient, AZ coefficient, and also the AX coefficient. Okay. And infinite sheet of charge, D3 is equal to rho S by 2 AN bar. That AN is a AZ bar. Okay, and all you can add as a point charge, line charge, and the surface charge. The first one having AX, AY, AZ, and second one having the AY and AZ, and third one having only the AZ. Okay, all the three having the AZ, and only the first one having the AX, and the remaining the two we have the AY. You can add all the terms, AX coefficient, AY coefficient, and we'll get the AZ coefficient also. Okay, that is for P is equal to, the charge is located at the 6 microcoulombs in the origin. At A 004 we find out the D bar, and B 124 we can find the D bar also. And the third one they're asking that total electric flux leaving the surface of the sphere 4 meters radius centered at the origin. The total electric flux leaving the surface of a sphere of 4 meter radius center at the origin. Okay, for that is the third one in this. Let us find the total charge enclosed by a sphere of radius 4 meters. The inside the charge is 6 microcoulombs at the origin. Okay, let us take here the sphere is like this. Inside there is a 6 microcoulombs. That is a Q1. And second one, the charge on that part of a line which is enclosed by a sphere. The line charge is intersects the sphere at x is equal to plus or minus 4. Hence, the charge on the length of 8 meters is enclosed by the sphere. So Q2 is equal to rho L into length enclosed. Okay, rho L into the length enclosed. This is a formula for the second one. Because it is a given, it is a rho L. What is a rho L? 1 and 180 to the power of minus 9, and total the meter is 8 meters. Okay, multiply that, we'll get the Q2 for the line charge density. And for the coming to the surface charge density, the intersection is at the z is equal to 0 prime, which is a sphere is circle with a radius of 4 meters. The formula the surface area is a pi r square. The surface area of the circle is S is equal to pi r square. R is given, it is a 4 meters. The total length enclosed here, the 4 plus 4 is 8 totally. We multiplied the rho L to get the Q2, and the Q1 is a point charge, and the last it is the S is equal to given 50.2 meters square. Okay, so let us see this one. The 4 meters from this origin means towards this one, the 4 meters, and towards that one is a 4 meters. Total is a 8 meters we have. So the charge Q3, the rho S into S. Rho S into S. Actually, the formula is how we got it is a rho L is equal to the change of charge with respect to the surface, not the surface, L. Rho S is equal to dq by ds. Okay, ds into rho S is equal to dq, or q is equal to rho S into SO. There is no any differentiation on both sides. Q is equal to rho S into S. What is the Q, rho S, and the S already we find that pi r square. We substitute here the 50.2. Then finally we get the 1.2 microcoulombs. At the point charge we got the Q1, and for the line charge we got the Q2, and the surface charge enclosed Q3. Total charge, not the total charge enclosed, nothing but the flux psi is equal to 8.69. The total electric flux leaving the surface of the sphere is, means inside the surface and outside the surface, leaving surface is both are the same. When you use Gauss law, the d bar dot ds bar is equal. Q is equal to the psi is equal. Understood? Got the Gauss law we are saying. Got it, my students? And you go for the next example. The flux density is given that D is equal to R by 3 AR bar nano coulomb per meter square. Is in the free space. Find E bar at R is equal to 0.2 meters and find the total electric flux leaving the sphere of a radius 0.2 meters and find the total charge within the sphere of R is equal to 0.3 meters. Got it, my students? Given it is a flux, they are asking the field. D bar is equal to R by 3 R bar nano. The D is equal to R by 3 AR bar nano, nothing but is a 10 power minus 9. The first they are asking that is a E bar is equal. So what is a E bar? The relation is a D bar by the epsilon naught. So D bar is given R by 3. Here the epsilon naught is there, 3 epsilon naught into AR bar nano 10 power minus 9. And given that it is a R is equal to 0.2 meters. Okay. 0.2 meters. So let us find that. We can substitute R 0.2 into here, the 10 power minus 9 is also there, by 3 into epsilon naught is a 8.854 into 10 power of minus 12 AR bar. Here the AR bar is there. Simplify by using your calculators, you get it is a 7.5 AR. Got it for the first one. And next one is find the total electric flux leaving the surface at R is equal to 0.2 meters. The gas law I told here, the Q is equal to psi is equal to integral d bar dot ds bar. D bar dot ds bar. D bar is given along the AR bar direction. AR bar means ds bar is also along the R direction. ds R bar is equal to differential surface area normal to the R direction. Sphere we are saying here, sphere means spherical coordinate system, r, theta and phi. Along the R direction, there is no any R component. R component is a dr, theta component is r into d theta, and phi component is r sine theta into d phi. Okay, these are the differential elements for spherical coordinate system. So differential surface area normal to the R direction means no dr, multiply the r d theta, r sine theta, d phi. So r into r is r square, sine theta, d theta and d phi. Okay, so this is ds bar is equal to R bar means along the direction of AR bar. D bar is given R by 3 TR. Substitute in the gas law, D bar dot ds bar, that D bar dot ds bar is equal to, what is a D bar? R by the 3 AR bar. AR bar dot AR bar is equal to 1. So the remaining is here R square sine theta, d theta, d phi. So R into R square is a R cube by 3 sine theta, d theta, d phi. So you can apply the integral to get the flux, total flux or electric flux leaving the sphere with the radius of 0.2 meters. Okay, the R you can substitute the 0.2 meters, 0.2 whole cube by 3 to simplify that one. You see here the integral is there. R cube by 3 is a constant and integral phi is 0 to 2 pi, theta is 0 to phi. Then you can substitute R is equal to 0.2, 4 by 3 pi into 0.2 whole cube. You get the 0.3. Let us take here. We got the Q is equal to R cube by 3. You can write in the outside because the integral values is phi and the theta is equal to 0 to 2 pi as a sine theta, d theta. Another integral we have, that is a phi is equal to 0 to 2 pi. Theta is a phi only, my student, sorry, is a phi. And here d phi into R. Now the charge, or it is a flux, d bar dot ds bar, R cube by 3 sine theta, integral is a minus cos theta, upper limit is a pi and lower limit is a 0. D phi integral is a phi, upper limit is a 2 pi and lower limit is a 0. Cos phi is a minus 1, cos 0 is a 1. Okay, 1 minus 1, cos phi is a minus 1 and cos 0 is a 1. Already there is a minus is there, minus into minus is a plus 2 value. And here the 2 pi, totally you get the 4 pi and R cube by 3 and 4 pi into 0.2 whole cube by 3. To simplify this one, we get 0.0335 nanocoulombs. And the C at R is equal to 0.3 and R is equal to 0.3. What is the flux they are asking? Okay. And the third one is find the total charge within the sphere of R is equal to 0.3. So you can substitute the same equation. Q is equal to 4 by 3 pi R cube. R is a 0.3, 0.113 nanocoulombs. Got it, my students? The next example is three concentric spherical surfaces having a radii R is equal to 3, 5, 7 centimeters respectively have uniform charge densities. Uniform charge densities 200, -50 and rho x microcoulomb per meter square. These are rho s, my dear students. So rho s is only the meter square, rho b is a meter cube, rho l is a meter only respectively. Find the d bar and e bar at R is equal to 2 centimeters, 4 centimeters and the 6 centimeters. And find the rho x if d bar is equal to 0 at R is equal to 7.32 centimeters. The given a concentric spherical surfaces R is equal to 3 with the radius 3, with the radius 5 and with the radius of 7. These are the concentric spherical surfaces. At R is equal to 2 centimeters, it is inner side of the inner sphere. It is seen that inside a spherical shell with the surface charge density E bar and D bar is equal to 0. Now R is equal to 2 centimeters is inside all the three spheres, hence E bar D bar is equal to 0. Means there is a radius of 2 meters. Let us take these are 3 and this one is a 5 and this radius is a 7. The given concentric three spherical systems. They are asking that the first one is a D bar and E bar you can find at R is equal to 2 centimeters, 4 centimeters and 6 centimeters. Now, the first if I am taking the R as a 2 centimeters, these are inside the circle. For all the three concentric, these are R2. So E bar and D bar is a 0 for the R is equal to 2 centimeters. If now this same R is equal to 4 centimeters means 4 centimeters above the value radius of the 3. Here this is a radius of 4. Means it is inside of 7 and 5 and outside of the 3 radii. Inside of 5 and 7 and outside of the 3. So R is equal to 4 centimeters, which is exterior to the innermost sphere, but inside the spheres of having radii of 5 and 7. Hence, at R is equal to 4 centimeters, the D bar and E bar exist due to the sphere of radius are 3, with the rho s is equal to 200 microcoulomb per meter square. First one. Got it, my dear students? See, why we are taking that is a 7 and 5 is not means there is no any effect of 7 and 5 on the 4 because it is inside. Previously, the radius of 2 is also, or the R is equal to 2 centimeters is not affected because the sphere of radius is a 3, 5 and the 7 outside. Now, the 4 centimeters is inside of 7 and 5. There is no any effect of that one. But there is an effect of the radius of 3 on these 4 centimeters. Got it, my dear friends? So for R is equal to 4 centimeters, it is for the existed due to the sphere of R is equal to 3 centimeters. So the formula the E bar is equal to rho s into A square by R square. A square is the values of concentric spheres and R is the radius of given. To find the E bar and D bar, 4 centimeters and 6 centimeters. So for 2 centimeters, we got the both the values is 0. For 4 centimeters, E bar is equal to rho s is given for 200 meters, 200 microcoulomb per meter square. Rho s A square. A square is a 3 into 10 to the power of minus 2 whole square, and the epsilon naught is 8.854 into 10 to the power of minus 12. and R square is 4. The given it is a 4 centimeters outside the 3 ER bar. You get E bar. Similarly, the D bar also epsilon naught into E bar. Remove that epsilon naught here. You get the 112.5 AR bar microcoulomb per meter square. Now, you can take the R is equal to 6 centimeters. R is equal to 6 centimeters means it is in between of 7 and 5 of the concentric spheres. Means it is inside of 7, so there is no any effect of 7. But it is outside of the spheres of 3 and the 5 concentric spheres. So the E bar and D bar will be due to the 2 spherical shells of having radii 3 and 5, while due to the sphere of R is equal to 7, D bar and E bar is a 0. But we'll get for the radii of 3 and the 5. Got it, my dear friend? So E1 bar I am finding. Why it is a E1 bar if I am taking? Because of radii is a 3 with the radius of 6 into 10 to the power of minus 2. You can substitute at the 200 10 power minus 6. Find the E1 and the D1 also. And R2 is equal to 5 centimeters. These are 3 centimeters A value. And we can get the E2 and the D2. When the A2 is a 5 into the power of minus 12, we get the E2 and the D2 also. The total electric field and the total electric flux E1 bar plus E2 bar is equal to 1.7255, and the D1 is D1 and D2 is a 15.27. Got it, my dear students? See what they are asking here. Find the electric and the magnetic, electric and electric flux for R is equal to 2 centimeters, R is equal to 4 centimeters, and R is equal to 6 centimeters. Because of giving the 3 and 5 radii of concentric spherical cells, spherical surfaces, R is inside, there is no any effect, so both are 0. And R is equal to 4, it is inside of 5 and 7, there is no any effect of 5 and 7, but there is effect of 3 because it's outside of the 3. And similarly, when R is equal to 6, it is inside of 7, there is no any effect of by using the 7, but is effect of 3 and 5. So you got the E1 and the D1 and D2 and D2. For the 3 and 5 you can find electric and the electric flux. Got it, my dear friends? Then the B also they are asking, find the rho x. What is the rho x here? Surface rho s. If D bar is equal to 0 at R is equal to 7.32. R is equal to 7.32 centimeters means definitely that is outside the circle. See here, is a dotted line given the outside the all the 3. If the 7 radius and the 3 and the 5 at R is equal to 7.32, all the shells produces the D bar. So D1 is a rho S1, A1 square R square. A1 is here, you can take as 7, and A2 is a 5, and A3 is a 3. But D bar is given the 0. At 7.32 centimeters is given, means D bar is equal to the total D1, D2, D3 is equal to 0. And you can substitute the R as a 7.32 centimeters. You'll get rho s is equal to, because the rho s1 and the rho s2, and here the rho s is there. Rho s1 is given as substituting here, and the rho s2 is also given. That what is the rho s here? So rho s is a minus 50 microcoulomb per meter square, and the rho x. So finally we get the rho x here. Rho x is equal to minus 11.224 microcoulomb per meter square. At this value of rho x, rho s, the D bar is equal to 0. D bar is equal to 0 with a radius of 7.32 centimeters. Got it, my dear students? It's a very important and is interesting also, my dear students. If this dotted line is inside all the circles with radius of 2, there is no any effect. And there is a 4 centimeters, there is no any effect of 7 and 5, only by using the 3. And if it is in between of 5 and 7, there is no any effect of 7, only the effect of 3 and 5. You can find the electric and the electric flux. And the second example, they're asking that find the rho x when the d bar is equal to 0, if the radius is outside all the circles. First one is a rho s1 and second one is a rho s2 and third one is a rho s. A1 we can find out here as 3 and A2 is minus 50. My A2 value here, the minus 200 into minus 50 to the power of minus 1, and A3 is a value given. A3 is a 7, A2 is a 5, and A3 is a A1 is a 3 centimeters. A1 is a 3 centimeters. So 3 into 10 to the power of 2 whole square, and similarly all the values you can substitute. You'll get the rho x is equal to. Got it, my dear students?